Hello everyone. Today we are going to discuss on the chapter function overloading. So let's try understanding what is function overloading. When two or more functions having same name but differ in number of arguments or data type, such functions are called as function overloading. Let's take an example. You have a function here. I have defined three different functions. So this is function name. I'm passing with no argument. Now, one more function passing as an integer. One more function where I'm passing character as an argument. Now if you look at this main program, I've defined two variables I and c. I is of type integer, c is of type character. Now this is function call. You are calling c, function name c. What is c here? C is a character. So when the function name matches with this character C, it directly goes here. If it matches here, goes inside, finishes its work and come back again. Next I'm calling function name I. So where is this I matching? I is a integer. So it goes here, it matches with this function, finishes its operation, come back again. Third function name, I'm not passing any argument here. So this function name is matched with first one. That means I'm not passing any argument here. So it matches here, goes inside, come back again. So this process is called as function overloading. In this example, you can see that there are function name having with same name, but you're passing with different number of arguments. Such functions are called as function overloading. Next we'll see what are the advantages of function overloading. Now as you can see, we are writing similar functions with different number of arguments. So by writing in this fashion, the code becomes very faster for compilation as well as for execution. Why it becomes faster? Because your function is comparing based on number of arguments in the function call. Another advantage of this function overloading is it's very easy to debug, as well as the flow of information is very easy to understand. We can also maintain the code very easy here. We have very easy interface between programs and real world objects. We have also one drawback of overloaded functions, that overloaded function must have different number of argument list. Why we need to have different number of argument list? It's just because if you write same argument list, the compiler gets confused as which function has to be executed. So that's the reason why we have to have a different number of list of argument while writing overloaded function. Now let's see how to declare an overloaded function and also how to define in our program. You can see here I've created two functions, that is product. I'm passing three arguments of type integer pqr. It is returning integer. Second function is also product, but I'm passing here three arguments which are of float type like x, y, z, and it is returning float. So this process is declaration of overloaded function. Let's see how to define it. Now this declaration part I have defined it here. So int product, int pqr, you are displaying the value of product pqr multiplied by pqr. Okay, so this is definition, this is declaration. Similarly, same definition for this product. So product passing arguments as xyz of type float, find the product, display the value, come out. So what difference are you finding within these two functions? Both the functions are almost same, but the difference is you are passing different data types and you are returning different data type. You can have same name, but you cannot have same data type. So this process is called as defining the function overloading, and this process is called as declaration of overloaded function. Remember, like we define our variables before using in a program, the same way we need to declare and then use it in a function for definition of a overloaded function. Now let's see the program to compute volume of a cube, cone, cuboid using overloaded functions. Now if you can see the program, I have included two header files. I have created a class called as function overload, and I have created three different functions. One is volume of a cube, the other one is volume of a cone, the other one is volume of cuboid. What I'm trying to find out here, trying to find out volume of a cube. So if you look at this overloaded functions, I'm trying to write the same function name like volume, volume, volume. But I'm passing three different arguments. Integer a, I'm passing two different arguments of double, passing three different arguments of type double. So here this function is to find volume of a cube. Second function is to find volume of cone. What is the formula? It's 0.33 into pi r square h. That is 0.33 into 3.14 into r into r into h. This is the formula to find out volume of a cone. Similarly, we have volume of cuboid, that is length into breadth into height. To find the volume of a cuboid, we are writing this function. Now what is the class? It's function overload. Name of a function is volume, volume, volume. Now I'm trying to create object of class function overload. It's F1. Then try to display the values of cube, cone and cuboid. How are you trying to call the function? I've created an object f1 dot volume. So f1 dot volume 10. So if the function matches with this one argument, it goes there, calculates, come back. If any function matches with two arguments, it matches with that function, calculates, come back. If any function matching with three arguments, calculates its value, returns and displays the value. So here is the arguments which you are passing to the function volume. So compiler decides based on the arguments as which function has to be executed. It's based on the number of arguments. So based on these arguments, it goes into the function, calculates the value of cone, cube, cuboid, gives you the output. Now let's see what is inline function. Inline function is nothing but a short function. When do we write these functions? Whenever we have one line of a code or two line of a code, we use this inline function. So what happens in inline function? Whenever you find a inline function, the compiler replaces a function call with the body of the function. Now, when compared to normal functions with inline functions, uh, in small functions what happens is if you want to call for several times in a program, there are certain overheads. What are these overheads? They are transferring of a control, returning a value, returning the control back to the calling function. Now these all overhead makes your program much slower and inefficient. So inline functions we use in such cases to overcome the overhead of normal functions. Remember one more thing, inline function always start with keyword inline. Inline function should be defined before all functions that call it. Now let's see how to write this inline function, and let's see what is the syntax of this. I told you whenever you write a function, the keyword inline should be used. So this is return type of a function, this is name of a function, and list of arguments, like for example integer a, comma b, comma c, comma d, and so on. These are executable statements and returning some value. Let's see a small difference between a program of inline function and normal function. And now you can see that there are two programs which are almost similar, but there is a small difference. If you look at this example, I have written a display function and printing the value of a. In my main program, I am displaying the value of 10. That means I am passing this 10 as an argument. It goes here, displays the value of a. Now what happens in inline function? I have defined this as an inline function. Can you see this keyword inline? I have defined inline. Now there is little bit difference between these two functions. Now when you are writing this display 10 in your normal program, what happens is you are transferring control from here to here. So your function call is happening, you are transferring the control, you are storing the values in stack, so you are taking more time for this execution. Now this won't happen in inline function. Why it won't happen? Because when you write this display, you are not transferring control from here to here like what was happening in this program. But what happens here? This code is directly copied over here. This code is directly copied over here. So your control is not transferring. Your compiler directly places this function here. So this is how you are reducing your time of execution. So that's how inline function helps us to increase the speed of our program. So when you write this display 10, you're not transferring your control, but this code is directly copied here, and again this display 10 when you're passing, again it displays the value of a as 10. There is no any change in the output within these two programs. Both the programs are showing you the same output, that is 10. But the only difference is in terms of execution of program. When you write inline function, your time of execution is been reduced. So remember when to use these inline functions. Whenever you have one or two lines of code, that time we need to use this inline functions. Let's see a small program to find the square of a number using inline function. Now I'm trying to find the square of a. I'm writing keyword inline. This is what inline function. Coming to a main program, I have two variables x and y. So x equal to square 5. Now what I'm doing, I'm not calling this function. I'm trying to put this a into a, that is 5 into 5 over here, and directly display the value of square of 5. Similarly, when you write y is equals to square of 10, you're not transferring the control over here. You're just pasting this code here and directly calculating its value, that is 10 into 10, and display the value. So when you execute the program, this is what you get an output. Square of 5 is 25, square of 10 is 100. Let's see what are the advantages of inline functions. Inline member functions are always a compact function calls. As I said, the speed of execution of program increases since we are writing for small programs, and the execution time will reduce here. Very efficient code can be generated. The readability of program increases. The size of object code is reduced. So these are some of the advantages of inline function. What is the disadvantage of inline function? Now, as I said, when you are using inline function, you are trying to increase the memory. How are you increasing the memory? Because as the body of inline function is substituted in the place of function call, the size of executable file increases, and for this you require more memory. So this is one of the disadvantage of inline function. Why it becomes disadvantage? Because whenever you are writing an inline function, and if you write 10 to 15 function call like a inline function, so there whenever you have function call for an inline function, there you are not calling, but you are just pasting that inline function to that particular function call. So if you write 10 to 15 function calls, there you are placing separate memory for this. So for that sake you require more memory, and this becomes one of your disadvantage. Please make note of these points. There are certain situations or certain scenarios where inline functions may not work. What are those reasons? Inline functions won't work if it is too complicated or the program is too long. Inline functions also won't work if you have recursive functions, or if you are dealing with looping constructs, or if you have some statements like switch or goto statements. Please make a note of this, because while writing an inline function, you should know what are the reasons when inline function will not be working. So now let us try to understand what you mean by friend function. A friend function is a non-member function used to access private or protected data members outside the class. So what is a friend function? It's nothing but a non-member function where you are giving an access to your private or protected data members to access it outside the class, somewhere outside the class, which is contradictory to C++ programming. What is C++ program rule tell us? Private members are accessible only within the class. But what we are doing here, we are trying to access the private data members outside the class. How is this possible? This is possible through function, and that function is nothing but friend function. Let's see how to write this friend function. Here is the syntax. You have class, class name, and this is a keyword friend. Your return type, name of a function, and argument. Remember, when you are dealing with friend function, you need to write this keyword friend while declaring, but not while defining. We'll see that in example. Now this is an example. I have created class base. I have two values, value 1 and value 2. I have created a getData function where you are accepting two values from the user, value 1 and value 2. This is your class. Name of a class is base. What is this? This is declaration of friend. So friend is a keyword, float is return type of function mean, and base. What is base? Base is a class, and OB is an object of base class. Now this becomes your declaration. This is your definition of your friend function. Remember, whenever you are dealing with friend function, you should not use friend while defining, but you should use friend while you are declaring it. So this is definition of friend function. So what we are doing in this friend function, we are trying to add two values, value 1 and value 2. Value 1 and value 2, and divide it by 2, find the average and return the value. But can you see that we are not adding the values directly as value 1 plus value 2. What are we doing here? We are using OB dot value 1 plus OB dot value 2. Why are we doing this? Because whenever we are dealing with friend function, we cannot access private members. Can you see this value and value 2? By default, these are private members of class base. We cannot access this outside the class. But since we are using friend function, we can access it. But how to access these variables? There is certain rule while dealing with private members. What you have to do is, you have to use name of an object with dot operator and the variable name like value 1. I cannot add this as value 1 plus value 2. When you are dealing with friend function, you have to use object with dot operator and value plus OB dot value 2, then the other calculations part. Remember, this is very important point. Whenever you are dealing with friend function, you have to use it with object name and dot member, dot operator, and then values. Now let's see one more example on friend function. I've defined two header files. I've created sample as a class. I have declared friend as a function print, which is returning void. Name of a function is print. Sample is name of a class. Friend is a keyword. I am writing a print function here. Print function, and sample is a class, yes is an object. So what I'm doing here, I'm trying to initialize the values of a and b as 10 and 20. As I told you, when you're dealing with friend function, you cannot access private members directly. What you have to do, you have to use it with object name with dot operator. So that's what I'm doing here. S dot a is equals to 10, s dot b is equals to 20. Display the values. This is your main program, sample s. So clear the screen. Print s. S is what? You're passing in an object, so your control transfers here. Assign the values of a and b, display the values of a and b. You have to make some note for this friend function, that a friend function, although not a member function, has full access right to the private and protected members of the class. It cannot access the member variables directly, and it has to use what? object name and member name. Okay, the function is declared with keyword friend, but while defining friend function you should not use keyword friend. So that was about friend function. Next sessions we'll see in next video. Thank you all.